EDX Core Pure, sequences in series 1, summing series. Looking at the sigma notation. So here we have the sigma notation showing us the sum of 2r starting at r equals 1 and stopping at r equals 5. So we can think of this as we need r to be 1, then r is 2, r is 3, r is 4, and r will be 5. When r equals 1, the term that we're dealing with is just 2 times 1. When r equals 2, this term becomes 2 times 2. Likewise, when r equals 3, this becomes 6. r equals 4, the term becomes 2 4s, which are 8. When r equals 5, we get 2 5s are 10. And don't forget, having worked out the terms, that sigma means the sum of. So we need to find the sum of these 5 terms, which we can easily add up now as 30. So here's another summation, now doing the sum of the term called 3r, but this time we're starting at r equals 4 and finishing at r equals 7. So if it helps, you can put those as little labels over the top. R equals 4, then r will become 5, then r will become 6, and finally r will stop at 7. So when r equals 4, that's where we're going to start. When r equals 4, we're going to get 3 times 4. Then when r equals 5, we're going to get 3 times 5. When r equals 6, we get 3 times 6. When r equals 7, we get 3 times 7. And again, don't forget that sigma means the sum of. We're going to add these terms together. So we're looking at 12, add 15, add 18, add 21, which is 66. Now this is another summation that can catch people out the first time they come across it. The sum of the term called 3, starting at r equals 1 and finishing at r equals n. Again, if we think of these little labels over the top, r equals 1, then r becomes 2, r is 3, and then we're going to go on to r equals n minus 1 and r equals n. When r equals 1, the term is simply called 3. When r equals 2, the term is still called 3. When r equals 3, the term is still 3. When r equals n minus 1, towards the end of this summation, the term is still called 3. And when r equals n, it is still called 3. And sigma means we need to add these together. So we've got 3 plus 3 plus 3 plus dot 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 plus 3 plus 3. In other words, we're adding 3 together n times. So this summation becomes n lots of 3, which would obviously write as 3n. So you can see it's 3, add 3, add 3, and you're doing that n times. So this time we're going to write the given sum in the sigma form. So we're going to reverse the process and turn the summation back into sigma notation. So if we just copy out the summation, so it's easier for me to annotate. And the key to writing this in the sigma notation is to think, how could I write this now in terms of r? So if we know the first term will be when r is 1, the second term will be when r is 2, third term when r is 3, and this, we can see if you look at the leading term in each bracket, we've got a 1 for the first term, 2 for the second term, 3 for the third term. So this one must be the 50th term. R is 50. So we need to write this in terms of the position in the pattern. So for example here, we can write this as we've got the 1 times, but think of 3 as 1 add 2. Then move on to the next term. We've already got the 2, but think of 4 as 2 add 2. On to the third term, we've got the 3, but think of 5 as 3 add 2. Dot, 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 we can miss out those terms. We don't have to do literally every term in the pattern. And then on to this 50th term, we think of this as 50 times 50 add 2. So now we can see that the first term we've written in terms of the 1 plus an extra 2. The second term has been written in terms of 2 with the extra 2. Every term has this plus 2 in the bracket. So the general term we can now write as every term as its position R, and every bracket is the position R plus an extra 2. And we're summing these terms together, starting at R equals 1 and finishing at R equals 50. So the key is to write the terms in terms of the position R in the pattern, as we can see there. So in the next session we're going to look at the standard formula for the sum to n terms of R.